Hello, uh, I'm Max Broussard. I'm here to talk to you today about torque. Torque is used every day. We use it when we open doors. We use it when we turn screwdrivers. It's a very simple concept, and I'm here to show you mathematically how it works. So the formula for torque is T equals Fd. Torque equals force times the distance of the lever arm. In the case of a door, let's say, the if you think about a door, why do you think the doorknob is always furthest away from the hinge? Why not is it placed in the center? Uh, in this case, with the torque formula, the lever arm is considered the distance from the hinge to the knob on the door. And the force is how much force it takes for a person to push or pull that door open. So, in the case of a door, if the doorknob was placed in the middle of the door, except instead of being on the outside of the door, your distance is cut in half, therefore decreasing your torque. If it takes the same amount of force for someone to push a door, let's say two people try to push a door, and one doorknob is placed in the center of the door, and the other doorknob is placed on the edge of the door, furthest away from the hinge. If they each use the same amount of force, the person pushing on the doorknob in the center will have less torque on the door than the person pushing from the further edge of the door. Why, you might ask? Well, if we take some simple numbers and we apply, let's just say each person, the force each person applies, let's just say it's 10 newtons. 10 newtons, writing it down on my card right here, 10 newtons. And that's force 1. And we'll call the force 1 will be, situation 1 will be the one pushing from the center of the door. So this is situation 1. And we'll say that their distance, we'll call that distance 1, is, throw a random number, 0.5 meters. And our distance 2, situation 2, they'll have the same force, 10 newtons, but for situation 2, the distance will be 1 meter, since you're further away from the hinge. So, if you can imagine, what do you think by just looking at the different numbers? And we know the formula, which is force times distance of the lever arm. If we do some simple calculations, we know that the torque in situation 1 of the door will be 5 Newton meters, while the torque on the door in situation 2 will be 10 Newton meters. If you can see that right there. So you can tell as you increase the distance from your radius point, which in the case of the door is your hinge, as you increase that distance, your torque also increases as well, with the same amount of force being applied. This situation can also be used on a wrench. Right here we have a crescent wrench. So on a crescent wrench, and we're going to use this screwdriver as our nut. If you're trying to turn this nut, and it's kind of tight, if I grab it and I try to hold this crescent wrench right here, and I try to turn, it's going to be a lot harder since my distance from my radius point, which happens to be right in here on the point of contact between the wrench and the screwdriver, and I have my hands placed right here, right by the neck of the wrench. If I try to turn, it'll be a lot harder than if I scooted my hands back to the edge of the wrench, increasing my distance from the radius point, giving me more torque so I can complete the job. Makes it a lot easier. You also see this when you're if you've ever rotated a tire before. If you're trying to your radius point is short, it takes a lot more force to get the job done than if you have what they call a cheater pipe, which is an extension for the wrench. You increase that radius distance exponentially, and then you're able to have it takes less force to complete the same job as it would having a shorter radius point. Yes. So that's all I got. That's torque.